Okay, in this video we're going to look at solving simultaneous equations. That's learning outcome 8.3 from the NCUK syllabus. So the first example we look at is simply solving by sketch. So if we sketch the lines y equals 2x minus 1 and y equals minus x plus 2, from where those two lines intersect, we should be able to read the point of intersection. That is, finding the one point that is common to both lines, where those two lines meet. So we'll just go across to the sketch pad. Now I'm going to, I'll be doing this by hand, so sketching is never the most accurate way of doing it, but let's get the axis going, and the y-axis we will show like that, and maybe the x-axis we will show like that, and label the axis x and y. Now the two lines we need to show are y equals 2x minus 1 and the second line we'll be looking at is y equals negative x plus 2. So if we look at the first one, 2x minus 1, well, we know when x is 0, y is, when x is 0, y must be negative 1. And likewise, we can maybe look at when y is 0. If we set y to 0, then we'll find x is half. So y is 0. We will find x is a half. So the point a half is 0 is another point on the first line. So we can, if we maybe call that 1 over 2, and we'll call this 1. Now we need negative 1, don't we? Negative 1 there. So this line is going like this. Now again, it's not the most accurate when you're doing it by hand or by eye. Let's look at the second line now. When x is 0, y is positive 2. So that's the y-intercept on the second line. That's negative 1. So boom, positive 1, positive 2 is up here somewhere. And we can look maybe when y is 0, x must be 2. So that's a half, that's 1, say 4 squares, 1, 2. Now we're going to, ooh, my straight line isn't very, very straight, but this is the point we have, so it looks to me, by sight, it's not very easy to read by sight. We call that 2, 1. Is it 1, 1? I couldn't be sure. It's 1 something. We'll call it 1, 1 by sight. Let's just check that by substitution, because I'm not happy with the drawing. So if we use by substitution, what we're doing is we're saying the point y is common to both lines. So if we say y is 2x minus 1 on the first line, well then where they meet, it must be true that both y's are the same, x plus 2. So let's rearrange, bringing the unknown x to the left. So we've got 2x plus x equals 2 plus 1. So we have 3x. 3x equals 3. So we do know the x value is definitely 1. Now to find the y, we just substitute in either of the two lines, so y equals 2 times 1 minus 1. So yes, y is 1. So we've just shown that the point of intersection is in fact 1, 1, even though the by graphing method doesn't look very accurate. Okay, so we can always use a plot to find the point of intersection. Let's look at a couple more examples now, and the second example is using the substitution method to solve the 2-degree system where y equals minus 3x plus 7, and the second line is y equals 2x minus 3. So let's go back to the math pad and we look at those two lines by substitution. So we've got y equals minus 3x plus 7, and the second line was y equals 2x minus 3. So the point of intersection, the value of y for both of these is the same. So if we say 2x minus 3. So we set these lines, these values of y equal to each other. And like in the last example, bring the unknowns to the left. So we've minus 3x minus 2x equals negative 3, negative 7. So we'll end up with minus 5x equals negative 10, which dividing out by the minus 5x will equal negative 10 divided by negative 5 is 2, positive 2. So that's the value of x, and when we have x, we now substitute the value of x into either equation. So we'll just say 2 times 2 minus 3, so y equals 1. So by substitution, we found the point of intersection is 2, 1. Okay, we'll do one more example now, this time using elimination method. And we have to use elimination in this case to find the point where the following lines meet. 2x minus 3y equals 4, and 3x plus 2y equals 5. So I'll just write those lines here to get started. So we have the first line, we'll call it line 1. Line 1 is 2x minus 3y equals 4. And line 2 is 3x plus 2y equals 5. By elimination, we're going to perform some operations on these equations to enable us to eliminate either x or y. And in this case, we'll eliminate x. So if I take line 1 and I multiply it by 3 times 3, we'll say that will become 6x minus 9y equals 12. And I'm going to take line 2 and I'm going to multiply line 2 by 2. And the reason I'm doing that is I will end up with a 6x, and this will allow me to eliminate x. So 6x plus 4y equals 10. To eliminate, I simply subtract from line 1, I'll subtract line 2. So the 6x minus 6x just eliminates that. So negative 9 minus 4 is negative 13. Negative 13, negative 13y. Negative 13y equals 2. So y in this case will be 2 over negative 13. Now we need a value for x and y, so we're going to use the value of y and find the corresponding value of x. So I'll just go up the top of the page again. Now that we know y is negative 2 over 13, and we can substitute that in and find x. 2x minus 3 times negative 2 over 13 equals 4. So 2x equals 4 minus 6 over 13. And let's just bring up the calculator. Why not? So we will have 4 minus 6 over 13. That'll give me 2x, which is 46 over 13. And we're going to divide the answer by 2 to get the final answer of x, 23 over 13. So if I haven't made a mistake, the final answer should be 23 over 13 is the value of x, while the value of y is negative 2 over 13. So that's where those two lines meet by elimination. Okay, that's all for this video. Thanks for watching.